Alright, Algebra, let's get going on this today. Lesson 8.4, Reflections of a Bike Lover. But, as always, before we get going into that math, guys, make sure you hit that like button, make sure you hit subscribe, and make sure you hit that notification bell so that you guys can see these videos as soon as they come out. Get that first like, get that first comment, because I know you guys live for that. So, let's go full screen. I don't know why it's not going full screen. Full screen! There we go. 8.4, Reflections of a Bike Lover. So this is a practice understanding task, meaning that we're building off of stuff that we just did in the last lesson. So all we're going to do right now is we're going to graph the function x squared minus 4. Now, if you guys want to build a table for this, you can. So let's build, you know what, let's just do it. Let's build a table. So we've got our x, and we have our f of x. And I'm going to go from -3 to 3. So, -3, let's plug it into our f of x. -3 squared is 9, minus 4 is 5. -2 squared is 4, minus 4 is 0. -1 squared is 1, minus 4 is -3. 0 squared is 0, minus 4 is -4. 1 squared is 1, minus 4 is -3. 2 squared is 4, minus 4 gets us 0. And 3 squared is 9, minus 4 gets us that 5. So if you guys remember, these are symmetric about this center right here. So now let's graph this. So at 0, we're going to be down at -4, so 1, 2, 3, 4. And I'm actually going to use a different color for this, because that's not showing up very well. I'm going to use green. So we're going to go down to 4, so 1, 2, 3, 4. And then if we go over 1 to the right, so at +1, we're going to be at -3. At -1, we'll be at 3. Then at 2, we're going to be up at 0. And at -2, we're going to be up at 0. And then at 3, we'll be up at 5. 1, 2, 3, 4, 5. And at -3, we'll also be up at 5. So let's draw this function in. So here's what this function looks like. Now what we're going to do in blue is we're going to graph the absolute value. So what I'm going to do is I'm going to add on to this table right here. And that's not going to work super well. So I'm going to draw a new table. We're going to draw a new table. So we're going to go f of x. I messed up. All right, I'm going to draw a new table that contains all of this stuff. So we're going to have our x, our f of x, and our g of x. So x is -3, -2, -1, 0, 1, 2, and 3. F of x, I'm just going to pull all these numbers and put them right where they were. So 5, 0, -3, -4, -3, 0, and 5. So now for g of x, what we're going to do is we're going to look at how far this is away from 0. So 5, of course, is 5 units away from 0. 0 is 0 units away from 0. -3, that's 3 units away from 0. -4 is 4 units away from 0. -3 again is 3 units away. 0 is 0. And 5 is 5 units away. So now in blue, we're going to graph this. All right, so of course, at -3, we're back up at 5. Same spot. At -2, we're at 0. Same spot. But here's where it changes. At -1, we're up at 3. So 1, 2, 3. At 0, we're up at 4. At 1, we're up at 3. At 2, we're back at 0. And at 3, we're back up at 5. So let's draw this function in. Man, that's a cool looking function. So now, explain what happens. So what we did is we had these spots where it dipped under 0. And so we started changing it. So we're going to cut it off here and here. And say that those are those ones where it switches. I'm going to draw these dots back in so we can see them. That's where it flips. So in between there, we're just taking a mirror image of it. So now we're going to write the piecewise function. So in here, we're going to have 3 parts. So g of x equals, well, for that first part, it's just the same. It's just that x squared minus 4. And then that happens from -infinity. So really, it's for x less than, what is that, -2? So for x less than -2. And then at the end, over here in this section over here, So this is the left section. So what we just did. The right section, again, we're just getting back to that x squared minus 4 for x greater than or equal to 2. But what's happening in the middle? So what's happening here is we just flipped it over that x-axis. So all we're doing is we're taking the opposite. So we're going to make it the opposite. We're going to make it negative x squared plus 4 for negative 2 less than or equal to x less than 2. So all we're doing, guys, is we're just taking the opposite. That's what's happening when we take these absolute values of functions. We're taking the opposite of that function. I hope that makes sense to you guys. So now here we're going to do the same thing. We're going to graph this function. So we're going to graph, and I'm going to draw my table over here because we're going to have another g of x. So we've got an x, f of x, and g of x. So x, again, we're going to go from negative 3 to 3. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. So now we're going to plug these in. So negative 3 plus 1 is negative 2. Negative 2 squared is 4. 4 minus 5 is 4 minus 9 is negative 5. Negative 2 plus 1 is 1. 1 squared is 1. 1 minus 9 gets us negative 8. Plug in negative 1. We get 0. 0 squared is 0, so we're going to be at negative 9. Plug in 0. We get 1 squared. 1 squared is 1, and 1 minus 9 is negative 8. Plug in 1. We get 2. 2 squared is 4. 4 minus 9 is negative 5. Plug in 2. 2 plus 1 is 3. 3 squared is 9. 9 minus 9 is 0. And then plug in 3. 3 plus 1 is 4. 4 squared is 16. 16 minus 9 is 7. So let's graph this. We're going to graph this in... Let's do it in green again. That was fun. So we're going to do this one in green. So at negative 3, we're down at negative 5. So 1, 2, 3, 4, 5. At negative 2, we're at negative 8. So we're going to be right down here. At negative 1, we're at negative 9. So that's going to be right here. At 0, we're up at negative 8 again. At 1, we're at negative 5. At 2, we're at 0. And at 3, we're up at 7. So 1, 2, 3, 4, 5, 6, 7. Now, this looks really lopsided. It looks like we have more of the right side of this parabola than we do the left. So we're just going to fill in spots. So at 2, we're at 0. Well, if we go 1 over from this, we're going to be at negative 4, 0. And then at negative 5, we're going to be up at 7. So you guys remember, these are symmetric about that vertex. Okay? As we can see from the vertex form, our vertex is at negative 1, negative 9. Now, let's look at g of x, because g of x is going to be weird here. How far is negative 5 from 0? Well, it's 5. How far is negative 8 from 0? It's 8 from 0. How far is negative 9 from 0? That's 9. How far is negative 8 from 0? 8. How far is negative 5 from 0? 5. How far is 0 from 0? It's 0. How far is 7 from 0? It's 7. So what we're going to do here is we're just going to put this in. So let's get our blue. At negative 3, we're up at 5. So at negative 3, we're up at 1, 2, 3, 4, 5. At negative 2, we're up at 8. Did I count wrong? Nope. So at negative 2, we're up at 8. So 1, 2, 3, 4, 5, 6, 7, 8. Man, they give us more on the positive than they did the negative. At negative 1, we're up at 9, which should be right about there. At 0, we're back at 8. At 1, we are up at 5. 1, 2, 3, 4, 5. At 0, or at 2, we're at 0. And then at 3, we're back up at 7. So we can see that if we were to fill out this left side again, we would just have these spots right here. So it would be coming down like this, and then it would go up, come back down, and then instantly bounce back up this way. And now let's graph our green parabola. Well, our green parabola, oops, I clicked on blue again. Green is going to come down this way. Honestly, I should have drawn this one in first, but that's okay. And now we'll color back in that section of blue so that we can see. Okay. So as you guys can see, we're breaking it off at, what is that, negative 1, 2, 3, 4. So we're breaking it off at negative 4. And we're breaking it off at 2. So when we're writing our piecewise function for g of x, those are going to be our spots. So g of x is equal to, make our curly bracket, and for the first part, our farthest left part, it's just going to be the original function. So it's going to be x plus 1 squared minus 9 from x less than negative 4, less than or equal to negative 4. And at the end, we're back at that x plus 1 squared minus 9, and that happens when x is greater than or equal to 2. Now, what's going on in the middle here? Well, if we're taking the opposite of it, we're just going to do a negative x plus 1 squared plus 9. We're going to take the opposite of everything in there. And that's from negative 4 less than x less than 2. So we're just identifying that the bounds where this is happening. And because it's happening between negative 4 and 2, well, we have to say it's happening between negative 4 and 2. So what do you think you have to what do you have to think about when writing any absolute value piecewise function? Well, what you have to think about is, where are these breaks happening? Where is it flipping? What's going on that way? What am I doing to the function to make it flip like that? Well, we're taking the opposite. So let's graph this. All right, and again, we're going to do it in green. Actually, I'm going to make my table first. So we have x and g of x. So let's go from 1 to 7. So we're going to go 1, 2, 3, 4, 5, 6, 7. And you guys will see why I did that. If you see here, what this is saying is that we're shifting it 4 to the right. So plug in 1. 1 squared is 1. 1 minus 4 is negative 3. But the absolute value of negative 3 is 3. Negative 3 is 3 away from 0. 3 plus 1 is 4. Plug in 2. 2 squared is 4. 4 minus 4 is 0. 0 plus 1 is 1. Plug in 3. 3 squared is 9. 9 minus 4 is 5. 5 plus 1 is 6. Now plug in 4. 4 squared is 16. 16 minus 4 is 12. 12 plus 1 is 13. Plug in 5. We get 25. 25 minus 4 is 21. Plus 1 is 22. Plug in 6. And as you guys can see, these are going off the way here. So let's graph this, how we have it. So we're going to go with x equals 1. We're going to go for 1, 2, 3, 4. At 2, we're going to be at 1. At 3, we're going to be at 6. So at 3, we're going to go 1, 2, 3, 4, 5, 6. Now, it looks to me like we need to graph some stuff on the other side. See, I may have judged this wrong. So let's look at the other side of this, guys. So x, g of x. Let's go from negative 3 to 0. We'll add on to this. So negative 3 squared is 9. 9 minus 4 is 5. And so 5 plus 1 is 6. Negative 2 squared is 4. 4 minus 4 is 0. Plus 1 is 1. Negative 1 squared is 1. Minus 4 is negative 3, which gets us the absolute value of negative 3 is 3. 3 plus 1 is 4. Plug in 0. 0 squared is 0. The absolute value of negative 4 is 4. 4 plus 1 is 5. So, do you guys see what I did there? I made a little bit of a mistake. See, when I was looking at this, I was saying, oh, we have a minus 4 inside this absolute value, so we must be shifting it. But I was doing that wrong. See, we would only be shifting it left or right if it was within the square, and it wasn't. So now let's graph these. At negative 3, we're back up at 6. So at negative 3, we're up at 6. At negative 2, we're at 1. At negative 1, we're at 4. And at 0, we're up at 5. So our function looks like this. This is our function. It looks like a W. It honestly looks like a W. So let's draw in our lines where we're going to break this up. So it looks like that happens at negative 2 and positive 2. So when we come over to our piecewise function, we're going to go g of x is equal to, and we're going to draw our curly bracket. So that first half is just an x squared minus 4. So we're going to have x squared minus 4. But then you got to remember, guys, that if we wanted to graph this, so let's see what it would look like if we didn't have that absolute value in there. So we're going down 1, 2, 3, 4, 5, and over 1. So then our next one's going to be down 3, 1, 2, 3 over 1, and then down 1 over 1. So this, and I'll draw that part in green, would be our regular parabola. So that's x squared minus 4 plus 1, or x squared minus 3, from x less than negative 2. And then at the end, we're back up at x squared minus 3, so we're back on that function for x greater than or equal to 2. But what's happening in between there? Well, we're going to have the negative of this. So if we make the negative, so it's negative x squared plus 4 plus 1, well, that's really negative x squared plus 5. From negative 2 less than or equal to x less than 2. So it's going on between that negative 2 and that positive 2. And guys, I'll do one more of these just to show you guys the way that I do these personally when we're looking at how to write out these piecewise functions for them. So let's go down here. This one's a little more complicated. So I don't immediately know off the top of my head where we're going to be doing this around. So I'm going to go x and g of x. And I'm going to go from negative 3 up to 3. So plug in negative 3. Negative 3 plus 2 is negative 1. Negative 1 squared is 1. 1 minus 4 is negative 3. But the absolute value of negative 3 is 3. So 3 plus 3 is 6. And you guys, I see that this is getting really complicated really fast, and I hope you guys see that. But it's not too bad. You just have to keep track of what step you're in. So negative 2. Negative 2 plus 2 is 0. 0 squared is 0. 0 minus 4 is negative 4. The absolute value of negative 4 is 4, so negative 4 is 4 away from 0. And 4 plus 3 is 7. All right, so then let's look at negative 1. Negative 1 plus 2 is 1. 1 squared is 1. 1 minus 4 is negative 3. But the absolute value of negative 3 is 3. 3 plus 3 is 6. Plug in 0. We get 2. So 2 squared is 4. 4 minus 4 gets us 0. 0 plus 3 is 3. Plug in 1. Well, 1 plus 2 is 3. 3 squared is 9. 9 minus 4 is 5. 5 plus 3 is 8. Plug in 2. 2 plus 2 is 4. 4 squared is 16. 16 minus 4 is 12. 12 plus 3 is 15. So I can see right there that we're already getting ahead of ourselves. That's way more than our y values go up to. So let's look the other way. It looks to me like this right here is going to be our vertex. This looks like our vertex, guys. I think that's it. Because you see how we have 6 and 6. So I'm going to go back to, let's go back to negative, I don't know, let's go back to negative 6. Negative 6, negative 5, negative 4. And let's plug those in. So negative 6 plus 2 is 4. 4 squared is 16. This feels familiar. 16 minus 2 is 12. 12 plus 3 is 15. I feel like we just saw that somewhere. Oh well, negative 5. So negative 5 plus 2 is negative 3. Negative 3 squared is 9. 9 minus 4 is 5. 5 plus 3 is 8. This feels really familiar, guys, and I can't put my finger on it, but it's so familiar. It's like right there on the tip of my tongue. Let's see what happens with negative 4. So negative 4 plus 2, that's negative 2. Negative 2 squared is 4. 4 minus 4 is 0. 0 plus 3 is 3. I feel like we just did find our vertex, because if you guys look at this, you can see that it's just repeating itself. So let's go down, let's go over to negative 2, and let's go down 7. 1, 2, 3, 4, 5, 6, 7. Luckily for us, 7's. Oops. Do you guys see what I did there? I went down to 7 when I should have gone up to 7. So 1, 2, 3, 4, 5, 6, 7. Okay. So let's look at negative 3. That's 6. So we're going down to 6. And then at 0, we're at 3. Sorry, I'm going the wrong way. I don't even know what I'm doing here. I need to go back over to negative 4. So at negative 4, we're at 3. But then at negative 5, we jump up to 8. Weird. All right, so let's go the other way. Negative 1, we're at 6. And then at 0, we're at 3. And then at 1, we're back up at 8. Let's make the pen a little bit thinner. Okay, so let's draw this. So we're coming down this way, and then we go up and around like that, and then we go up like that. Okay. So our breaks here, if you guys look at it, I'm going to do them in green. Our breaks are happening right here at negative 4 and 0. So let's draw our piecewise function. Let's figure out what it has to be. So, g of x equals, well, I know I have 3 parts to this. So the first part's going to be the positive. So what we're going to do, and I told you guys I would show you this way. So what we're going to do is we're just going to take the positive of this. So we're just going to leave it x squared, or sorry, not x squared, x plus 2 squared minus 4 plus 3. Which means that it's going to be x plus 2 squared minus 1. Okay, so then for that first part, that's our function. X plus 2 squared minus 1. For x less than, what is that, negative 4? Less than or equal to negative 4. And then at the end, we know that we're going to be at this same place. We're going to be using the same function. So we're going to be x plus 2 squared minus 1 for x greater than 0. But what's going on in between? Well, in order to find that out, we're going to make the inside here the opposite, inside of this absolute value. So we're going to get negative x plus 2 squared plus 4 plus 3. So we're going to have negative x plus 2 squared plus 7. That makes sense, because if you guys think about it, what this is telling us in our transformations is that we're shifting it left 2 and up 7, and we're flipping it so that it opens down. So we have negative x plus 2 squared plus 7 for negative 4 less than x less than or equal to 0. Now, I'm going to let you guys try out number 12 on your own, because number 12 is it's a great function. All right, these are just an absolute blast. Exponential functions are so cool, and it's kind of something we've already done before. So I want you guys to think about that. So go ahead and do number 12 on your own, and that is it for this, guys. But make sure you guys are working on these right set goes, because this will get you ready for geometry. That's why they're including it now, because we're towards the end of the year, and next year you guys will be taking geometry. So, as always, guys, before I end this video, make sure you guys hit like, make sure you hit subscribe, and ring that notification bell so that you guys can see these videos as soon as they come out and get notified when they come out. As always, guys, have a great rest of the day. Hope you enjoyed the math, and I hope you guys learned something, which is what these videos are for, especially since we're in quarantine.